Hello everyone. So today we shall begin with the second chapter in the COA subject of BCA third semester, that is integrated circuits and digital functions. Before going to know what all are there in the chapter, we shall study what is integrated circuit. So in the first chapter we studied what is logic gate and how many logic gates are there and or not, everything we studied. So what was there in that? See, if you observe the logic symbol, take for example AND gate. Okay, so what is there in this logic symbol? We have two inputs and one output, and there is one output expression for that. For example, A, B, and what is the output expression for AND gate? That is AB. Okay. For example, if the expression becomes lengthier, take for example AB plus CD. In this case, how to draw the logic diagram? See, first AB, next CD. Next, you need to add these two using OR gate. So this is AB plus CD. See, when the expression was just AB, only this much was the logic diagram. When the length of the expression increased, and again the complexity of the logic diagram also increased. So this is how, if the length of the logical expression increases, for example, AB plus CD plus AB bar plus A XOR B plus and so on. So you just think or you just imagine, if the length of the logical expression increases in this level, then what might be the complexity of the logic diagram? Okay, so in order to reduce that complexity, okay, we need to have one miniaturized figure for this, miniaturized concept you can see, or a miniaturized device you can see, with desired reliability. Okay, so in order to reduce the complexity, or you can say when the logic circuits complexity increases, then we need a device. So what is integrated circuit? Integrated circuit is nothing but the complex logic circuits are miniaturized with a desired reliability into a single piece of silicon wafer called as integrated circuit. Once again, what is integrated circuit? The complex logic circuits are miniaturized, nothing but minimized, with desired reliability to a single piece of silicon wafer. Okay, wafer is nothing but a plate. Okay, it looks like a plate. So silicon wafer, that is nothing but integrated circuit. Okay, so these integrated circuits are classified based on number of gates we are going to use in that integrated circuit. Okay, so let us consider the classification. So, SSI is nothing but small scale integration. SSI, small scale integration. MSI, medium scale integration. LSI, large scale integration. VLSI, very large scale integration. Okay, so now how these are classified? As I told you than 10 logic gates. And this SSI ICs are used to perform simple digital logic functions. Next, coming to MSI, that is medium scale integration. Here we will be using 10 to 100 logic gates. Okay, and these ICs are used in decoders, adders, nothing but half adder, full adder, which we studied. So in these are used medium scale integration. Next, large scale integration. Here it will be having 100 to 1000 logic gates, okay, which are used in processors, memories, and programmable devices. Okay, so there these are used. Next, coming to VLSI, very large scale integration. So here usually thousands of logic gates are used, more than 1000 can be used, and these are used in complex, large arrays, memory arrays, and then complex microprocessor chips or microcontroller chips. So in those systems, these are being used. So this is about brief information regarding the classification of integrated circuit based on the number of logic gates used in that device. Okay. Now let us begin with the decoder. So what is this decoder? You might have heard the name decoder. So this decoder is nothing but it decodes information. Nothing but it converts binary information from n number of inputs to 2 raised to n number of unique outputs. Okay, and these are used in monitors and printers, then calculator, displays. In those we need decoders. Okay, so as I told you, it is very easy to remember. It converts n number of inputs to 2 raised to n number of outputs. Okay, and it converts binary information from n number of inputs to 2 raised to n number of outputs. Okay, and the block diagram will be like this. 0, 1, 2, 3, n minus 1, and the last one is n. And here also the same thing, 0, 1, m minus 1, and here is m. And this m may be less than or equal to 2 raised to n. Okay, and this is decoder. So this is how the block diagram of the decoder looks like. Okay, so this is about just introduction about decoder. Now let us study one example. That is 3:8 decoder. See here the name itself indicates how many inputs are there and how many outputs are there. So here 3 inputs are there and 8 outputs are there. Okay, so the first let us write the truth table for this. Okay. ABC. You can name it as A0, A1, A2, whatever. So then outputs D0, D1 up to D7. Then what is this enable input? See, this enable input acts like a switch. Switch in the sense, whenever you want to switch on a device, take for example fan or tube, there will be a switch. If you switch it on, then only the device works. When it is switched off, then the device doesn't work. So similarly here, when the enable switch is on, okay, when it is 1, then only it works. Otherwise it won't work. See, for example, if the enable switch is 0, okay, then whatever may be the combination of input, this is called as a don't care term. Don't care term means it may be either 0 or 1. So whatever may be the combination of the inputs, the output will be 0. Because the system doesn't work because the main switch is off. Okay. Now, when it is switched on, then let us consider 3-bit input combination. So 0, 0, 0. Okay. So here, for every combination of inputs, only one output will be there. Okay. 0, 0, 0 means D0. That is 0. So this will be on and remaining will be off. That means when the input combination is 0, 0, 0, then the output will be D0. It means the other outputs are not present. Next, of course, enable has to be 1. Then 0, 0, 1. 1 means D1. This will be the output and remaining are not the outputs. Only one output appears at a time. Next, 2. Next, 3. Next, 4. D4. Next, 5 means D5. Next, D6. Next, D7. Okay, and the enable has to be 1. If it is 0, then the system won't work. So this is very simple if you understand. So what is there here? 3-bit binary combination, 0, D0, 1, D1, 2, D2, 3, D2, up to 7, D7, and others will be 0. So this is about the truth table of the decoder 3:8. Now coming to the logic diagram. See, logic diagram is also very simple. We have to consider the inputs first. Okay. So let us consider the inputs. So we have 3 inputs. See, I am taking not gate here because see the lines are nothing but 1, and if we take not gate, that becomes 0, because see every input may be either 0 or 1. So we must have both the lines. So this line is 1 and this line is 0. Similarly for BC. Okay, so now, so this is about input lines. Now consider the output. D0. When the output is D0, when the input combination is 0, 0, 0. Okay, so which line we have to consider? Not line we have to consider. Okay, so this indicates 0 and this line indicates 1. Okay, so now 0, 0, 0 means this line. Put and read. So this is the output. This is the first output. Now similarly, when D2 is output, when the input is 0, 0, 1, means only C is 1. C is 1 means AB we have to take not lines and C we have to take this line. So 0, 0 and 1. Take and repeat. The output is D1. Similarly, D2 means 2. 2 means 0, 1, 0. 0, 1, 0. D2. Next, 3. 3 means 0, 1, 1. So, 0, 1 and 1. D3. So this is how we have to take the outputs till 1, 1, 1. What is 1, 1, 1? 1, 1 and this is 1. So this is how we have to draw the logic diagram, and one more is there, that is enable. So enable switch must be there. So that will take at the end here. Enable. Let us connect enable everywhere. Okay. So this is how enabling is connected. So every output is having 4 inputs, 3 ABC and one more is enable. So this is how the 3:8 decoder works. So what is 3:8 decoder definition? Decoder, it is a digital logic circuit which converts binary information from 3 inputs to 8 unique outputs. So that will be the definition. And how to draw the block diagram of this, that I tell you now. See, block diagram is very simple. Inputs we have, that is ABC. Okay, outputs. So this is very simple to draw the block diagram. So this is very important question from the exam point of view. Okay, so explain 3:8 decoder means you need to define it first thing, and then you need to draw the block diagram, then you need to write the truth table, okay, then you need to draw this logic diagram completely, which is not complete here because I need to draw D4, D5, D6 also. So complete logic diagram, and then you need to explain how it works or the operation of the decoder. So how it works is nothing but, so decoder definition, then enable will be there. Enable is also considered as input, one of the inputs. So enable acts like a switch. When enable is enabled, okay, as the name indicates, when enable is enabled, that is when enable is 1, then only the device works, or the device is switched on when enable is 1. Okay, when enable is 0, then the whole device will be switched off. So when enable is 0, whatever may be the input combination, the output doesn't work, or the whole device doesn't work. And when enable is 0, you won't get any output. Okay, so this is about the operation. And see, for every input combination, you will be having one unique output. Why it is called as unique output? Because that output doesn't change. For example, when D0 appears, only when the input combination is 0, 0, 0. Okay, if it is changed, then D0 won't appear. Some other output will appear. That's why it is called as a unique output. And this decoder circuit circuits are used in printers, monitors, as I told you, okay, and calculator displays. Okay, so this is about the application of the decoder. Okay, so I hope you understood. And truth table is also very easy. Logic diagram is also very easy. Go through this, okay, till you understand. And in the next class, we will study encoders, which does operation exactly